Neural networks are one of the core building blocks of modern artificial intelligence. They are often mentioned alongside deep learning, machine learning, and AI systems such as image recognition or language models. But what exactly is a neural network, and why is it so important? In this video, I'll explain neural networks in a simple and intuitive way. Let's start with the basic idea. A neural network is a mathematical model designed to recognize patterns in data. It is inspired by the human brain, but it is not a real brain, and it does not think, reason, or understand. The inspiration comes from the way biological neurons are connected, not from how humans form ideas or make decisions. A neural network is made of three main parts. The first part is the input layer. This is where data enters the system. The inputs can be numbers, pixels from an image, words from text, or measurements from sensors. Each input is simply a value with no meaning on its own. The second part is one or more hidden layers. These are the layers where most of the processing happens. Each hidden layer contains units called neurons. A neuron takes the input values it receives, applies a mathematical calculation, and produces an output. That output is then passed to the next layer in the network. The final part is the output layer. This layer produces the result. For example, it might output a prediction, a category, or a probability. To make this more concrete, imagine a system trained to recognize handwritten numbers. The input layer receives pixel values from an image. The hidden layers analyze patterns in those pixels, such as edges, curves, and shapes. As information moves through the layers, the patterns become more abstract. The output layer then produces a number from 0 to 9 as the final prediction. Each neuron in a neural network has something called a weight. Weights control how important each input is to that neuron. Some inputs matter more than others, and weights represent that importance. During training, the network adjusts these weights to improve its predictions. This training process is what allows neural networks to learn from data. The system makes a prediction, compares it to the correct answer, and measures the error. Based on that error, the weights are slightly adjusted to reduce mistakes in the future. This process is repeated many times, often millions of times, using large data sets. Over time, the network becomes better at recognizing patterns and making predictions. At this point, it's useful to pause and think about what learning really means in a neural network. When a neural network learns, it is not memorizing examples the way humans do. Instead, it is gradually shaping an internal structure that responds differently to different inputs. This structure is made entirely of numbers. There are no concepts, symbols, or understanding inside the system, only mathematical relationships. As training continues, the network becomes better at reacting to familiar patterns. It's important to understand what neural networks can and cannot do. They do not understand meaning. They do not have awareness, emotions, or intentions. They do not know why a result is correct. They simply detect statistical relationships in the data they are trained on. Neural networks are very powerful when dealing with complex and unstructured data. They are especially effective for tasks like image recognition, speech recognition, language translation, and pattern detection. This is why they are used in many modern AI applications. However, neural networks also have clear limitations. They require large amounts of data and computing power. They can learn biases present in the data, and in many cases, it is difficult to explain exactly how they arrived at a specific decision. This lack of transparency is often called the black box problem. Despite these limitations, neural networks remain one of the most important tools in artificial intelligence. They allow machines to perform tasks that were once extremely difficult or impossible to automate, but they are still tools, not intelligent beings. They follow mathematical rules and learned patterns, nothing more. If you want clear explanations of AI and technology without hype or jargon, subscribe to AI and Tech Explained.